So, hello everyone. My name is Andrey Garifov, and I'm going to tell you today about simulation modeling. First of all, I want to tell you about our company, about myself, and then tell about simulation modeling methods, tools, and our product which we use in our projects. This is AnyLogic and AnyLogistix. Then we will talk about AnyLogic libraries and different kinds of experiments, and look at some of our cases. Those cases are airport, screw manufacturing, and autoclaved concrete factory. I will show you dynamic models, and we will check it out. Yeah, so our company is called NFP, and we have several departments. I'm head of simulation modeling departments, and other departments are business consulting department, or RPA department. They develop robots for business. And also we implement 1C projects and SAP projects. Today we're talking about simulation modeling. So the first model which I will show is one of our models. It is a model of an international airport, which is in Russia, in a town which is called Tomsk. So this is AnyLogic interface, and this is a simulation parameters for our model. The model simulates the functioning of the Bogashovo airport in Tomsk, Russia. The duration of simulation is 12 hours, and the passengers go through security, check-in, customs, and passport control, pre-flight control, depending on their flight. They can have, for example, internal flight or external flight, international flight. And the model can help us to analyze dependence between airport services and its parameters, and some factors of airport efficiency, for example, utilization of staff. We can change some parameters on input, for example, some general parameters, when the check-in starts, when the boarding starts, or how long check-in takes, or how much people go to red corridor at customs and how much to green, and different time parameters for different controls. Now let us run the model and look what happens. So this is our model. We have two floors on our airport. Ground floor, which has check-in and escalator, and the first floor, where people go and then they leave to their flight. Every kind of passengers has its own route where they go. For example, internal passengers who want to fly inside Russia come in there, and then they go to check in, and then they go to customs and go to the first floor. At the first floor, they get another check, and then go to waiting area. Let's invite some passengers inside. Also, we have time in the right corner, and okay, our passengers, here they are. So they come inside, go through check-in, go through customs, and go to the first floor to get another check, pre-flight control, I believe. And then they wait for their flight. Okay, let's run as fast as possible. Yeah, so our passengers left. Now we're waiting for other passengers on the ground floor. Okay, then as you saw, some international flight passengers came and left through this door. And some internal flight, maybe they're still on the first floor. No, they left. So with this model, we can analyze different statistics from the modeling. For example, we can look at the utilization of entrance security control. As we see, for international clients, the utilization is low because people do not come all the time. They come when their flight comes. The check-in, the passport control. For example, passport control, as we see at 5:56, arrived some passengers, and the utilization rised. Pre-flight control. As we see on pre-flight control, mostly come international passengers, and utilization is pretty high, 40%. And we have mean service time on each service. Okay, if you do not have any questions about this model, we'll go on and look at the screw manufacturing model. By the way, there is really a lot of passengers right now, but all they're okay. Yeah. The second case in our webinar is screw manufacturing. It is based on our project, which we made for the biggest metallurgy producer in Russia, and this model is based on that one. So this model was designed to demonstrate the capabilities. It is not a real model from the project. And it demonstrates the production cycle of a metalware plant. During the simulation, we can stop production lines, for example, to cause critical situations and to analyze the performance of the system. So we have a truck which puts raw materials in the area, and we have a crane. The crane takes raw materials, puts in buffer zone, and then from the buffer zone it puts it on machines. In this model there are two kinds of machines, orange ones and blue ones. First the raw materials go to orange one, the cutting machine, and then they go to blue one, thread machine. After this, a little forklift comes and takes boxes with final goods to other lines. So this line is galvanizing line, and this is also a galvanizing line, but more powerful. And this is packaging area. So after galvanizing, final goods go to packaging, and inside big boxes they come to this area and live on a truck. As you see, we have different colors of equipment. If the equipment is colorful, it works right now, and if it is gray, so it means it is currently not working. We can for example, switch off the galvanizing line and make the time move faster, and look at this buffer area. As you see, the line is switched off and the area is more and more full. After some time, the bottleneck will arise at this place, and we will have a problem because we will need to stop those machines. Okay. Yeah, and we can see a lack of space. For example, now it is about 182%. So actually, to store all these goods, we need an area that is 3 times bigger than this one. We can switch it on, the galvanizing line, and look what happens next. Lack of space goes down, and in some time it will be okay again. The model provides some statistics which we can use. For example, we have utilization of equipment. For cutting machines right now it is 87%. For thread machines it is 74%. For galvanizing it's 62%. And for packaging 60%. And also we have produced amounts. So for example, the first line, the cutting machines produced 570 tons of goods, and the packaging is right now producing only 500 of final goods. So we can now tell that we have about 100 tons inside the system. Okay, so this was a screw manufacturing model based on a project. By the way, the model is available on AnyLogic Cloud. After the webinar, we will send it with all materials, and you can check it out by yourself, play with these buttons with different scenarios, and look what happens.